Okay, so in the next video, we'll go over addressing modes in ARM architecture or ARM language, assembly language. But before we really dive too deep into addressing mode, we probably should also visit the load and store instruction, because if we don't know how the load and store work, we probably won't understand how the addressing mode also works. And if you know from other languages, addressing modes is basically how would you get values transferred in your CPU. So like if you're familiar with maybe the MIPS programming language, you will have like immediate addressing, you have the register immediate, you have the offset addressing, and so on. In ARM, there is a few. There is like the register immediate, there is an offset, there's pre-index, post-index, and so on. There's about 9. We'll probably go over, we'll see if we can finish all of them. So let's talk about well, let's do an example here. So if I would like to move data into a register, I showed you before, we can use the LDR, and then we can say, okay, well, we can all either use an immediate value. In this case, I can move some value like 14 into R0. But in this video, I'm more interested in showing you how to move data from the memory into the registers and what different variations of this load store stuff you can do. So assuming we have a variable x that has a value of, let's just say, 15. So this is taking a word space or 4 bytes space to store the value of 15. And I would like to move it into R0. So first I make a pointer that points to that variable. In this case, it's x. And then I load a value into R0 from where R0 is pointing to. If this is confusing to you, you can replace that R0, the first one, with R1. So basically, this reads as make a pointer that's pointing to x somewhere in memory, and then grab a word from that location and put that into R1. So if we compile it, we'll see it works. Okay, so if we step through it, now my pointer R0 is pointing to some address in memory that happens to be 10000000. And then if I go to memory and I look at that address, let me actually grab it from here. And I go to that address, that will be the address right here, and then that address contains 15. 15 in hex is F. So if I step one more time through the code, I will see that F has been loaded into R1. So far, pretty straightforward. We have a variable that takes 4 bytes. It contains the value 15. I made a pointer that points to the address of that X or of that variable. And then I moved a word from that variable into R1. Now, let's do a few more things. Let's make this a little bit more interesting. So let's add more values here. So let's say, let's start with 10, 11, 12, 13, 14, and 15. So essentially, I have an array that's starting at some address is pointed to, or in this case, it's X contains 11, 10, 11, 12, 13, 14, 15. Let's run this code again and see what happens if I'm loading a value from that address into R0. Okay, so if I do that, I'm loading the address of X into R0, and then I'm getting the first value from that location, which happens to be 10. 10 decimal is A in hex, so I'm loading 10 into R1. I go to memory, and I go to that address. I will see my A, B, C, D, E, F. So that's 10, 11, 12, 13, 14, and 15. But how would I go and grab the next data from that address? So I need to get the next element of X. How do I do that? Well, if I type another instruction like this one, let's say I have LDR R2, where R0 is referring to, it's going to grab the same element. It's going to grab 10 and put it in R2 as well, because I'm not advancing, quote unquote, the pointer. in this case, right? So if I compile it and load it, you'll see what I'm talking about. So there must be a way to advance the pointer after or before I grab an element from a specific address. And that's where the addressing modes in ARM actually will make a lot of sense. So here, let me do this. I point to that address 10000000, and then I will grab A or 10, put it into R1, and then if I step again, I'm also getting A, putting it into R2. So one way to fix this is actually to increment the pointer after I grab the element from that address, and I can do that by specifying a value of increment. In this case, I'm incrementing by 4. So on the next step, I will grab the value from the next word location. So let's compile and load this into the board, and we'll see what happens. Okay, so if I step through my code, I'm pointing to that location, then I'm going to grab a word from that location, put it into R1, and then increment the pointer by 4. So when I click on the next step, you will see that the value of R1 will change and the value of R0 will change. So R1 now contains A, which is the value of 10, and R1 contains the previous address plus 4, okay? And if I click on the next instruction, now I have B stored into R2. And what happened here was, originally, the pointer was pointing to this location, which contains A, and to go into the next word location. Now, the key here is like the next word location, I'm going to grab the next word, and the next word happened to be a B or 11. So the question comes in then, can we increment by numbers that are not 4? And the answer is yes, I can increment actually by 1. I can increment by 2. But if I do that, I'm going to increment the pointer by 1. So instead of it being pointing to this 0A and grabbing a word starting at this location, at location 10000000, it's going to grab a word from location 10000001. So it's going to grab this first byte and this one and this one, and then the 1 byte from the next segment. So actually, let's do this here before we go. I'll show you what kind of error, well, not error, what would you expect if you increment only by 1 if you're dealing with a word array. And what I'm trying to say here is that you need to be careful with what data elements you have and how much you're incrementing the pointer by. So if you're dealing with words, let's do this, and then that will make sense. So increment by 1, then grab the next element. So if you see R2 now contains a value that's not B, that's not what I meant, that's not what I intended to have. Simply grabbing 1 from the lowest, this is, B is 10111. It's grabbing one of these bits and putting here, and that's why you see 1, but that's not true. So just be careful when you're dealing with elements of a certain size. The pointer must be incremented by a value that matches the size of that element. And nonetheless, so this will bring me to the next kind of segment of this video, which is what kind of like how do we load and store different values, or how do we advance the pointer with a specific number? Anyway, so there is a lot to cover here. I'll try to be brief. So let me give you this example. So I'm going to put maybe, let's say, a message. Let me type. So message, and I'm going to define an ASCII string. Okay, so let's call this an alphabet. So I'm gonna go A, B, C, D, E, F, G, H, I, J, K, L, O, P, etc. You got the idea. I just want to show you something. We don't have to do the whole thing. Now I'm going to make a pointer that's pointing to that location So this is going to point to message. And we'll try a few things. First, I'm going to go over the different types of load instructions that I have. I can load a word into a register. So this register will be, let's say, R1, and this will load a word from R0. I can load half a word, actually. I can load half a word. Again, let's put that into R2 from this location. I can load a byte, LDRB, and let's put that into R3. And that will be from R0. So if I execute this code, I will see, when I load a word, I should see 1, 2, 3, 4 characters being put into R1. If I load half a word, I'll just see 2 characters. And if I load a byte, I will see 1 character. And the reason is, when you a character is 1 byte, and obviously if you have a word, that's 4 bytes, so that's 4 characters, and that's how I'm basing this calculation. Okay, let's step through the code. So again, this is pointing to the message variable. I'm loading the first I load it when I execute this LDR R1 R0. I loaded 61, 62, 63, 64, which are the hex value of the ASCII characters A, B, C, D. Lowercase a is 61, and then B is 62, C is 63, and so on. So now if I do the next one, I'm loading half a word, so I only loaded 61 and 62, and you see the remaining bits are 0. And then obviously if I execute the last one, I'm loading a byte, so I only have the 61 here. So this is the variation I wanted to show you with the load. I will show you the store instruction, and then we'll talk about the addressing mode in a different video. So let's say I want to store things back into memory. I simply use the str, and then it is very similar to the LDR. So you kind of store a word, you kind of store a half word, and you kind of store a byte, and it's the same format. So I can store the content of some register, let's say R1, into an address, let's say R0. I can store, again, the content of R2, that I'm storing a half a word into the pointer or the address that's pointed to by R0, and then I can store a byte into the address pointed to by R0. And before we store it back, let me change the value of R1, R2, and R3, and then we store them into these locations. So I'm going to increment them by 1. I'm going to add R1 to itself and add 1 to it. And I'm going to do the same thing for the remaining, for the next 2 registers. So I'm going to add R2 to itself, increment that by 1, add R3, sorry, to itself, add 1 to R3 and store it back into R3. So now if I execute this code, okay, if I go through the first steps, now I'm incrementing R1 by 1, R2 by 1, and R3 by 1. Now notice that, only the lowest bit was incremented. So like I went to 62, from 61 to 62, 62, and 62. The remaining values won't change because I just added 1. Now I'm storing back this value into that address. So actually, to do that, to show you the effect, it will make more sense to go to the memory and see what's happening here. So if I write that back into memory, now you see this turned into red, meaning that this value has changed, and it actually did, from 64, 63, 62, 61 into 64, 63, 62, and 61. If I store the other ones back, I will not see a change because it's still writing half a word. That's the same half word I have here. So I'm going to still see 62 and 62. And if I execute the last one, I will still get 62 and 62. But you get the idea. I can actually, you like, we can make another, destination source here. Maybe we can call this for DES, and we can specify a word, and then you can specify a 0, and then you can make let's say here, make R4 pointing to that DES place, and then store we can do this one maybe. Yeah. Just want to show you that you can store a byte. Actually, it will only store the byte. So that's why I'm doing that. So basically, I'm going to grab a byte from that location, increment it by 1, which is right here, and then I'm going to store it into the address pointed to by R4. So if I go to memory, let's step through the code. Just run down to here. And now R4 is going to point to the location of that DES space. And then if I go there, it's at address 15. Right, so it's got to be here. Okay. So it's right here. And if I write to it, now I did write a byte into that location with this store byte instruction. And if you look closely, right, so this is address, this is 10, right, where 71 is, this is 10, 11, 12, 13, then address 14 contains a 75, and address 15 contains a 62, which I just stored. That's the basics of load and store instructions in ARM. In the next video, we'll talk a little bit more about incrementing and decrementing the pointers using post and pre-indexed variations. Thank you.